9.3.3, we're looking at a geometric series, which if you remember right is the sum of the terms in a sequence. So we can have an infinite series or a finite series, and we can always find the sum of a finite series, and an infinite sometimes, sometimes not. So we find that if possible. All right, so let me see. So in our yellow box here, we have evaluating a finite geometric series. So here's our formula to evaluate the geometric sequences. This is for a finite. This is a formula for finite. Note that. That formula is derived in your book, which you can review. We're going to focus on the application in this video. And yeah, so we're going to do finite first. And then in the next video, we'll do infinite. Okay, so one thing to note in this formula, I can actually write it like this as well. That's just adding each piece and expressing that in some summation notation. But notice that that k equals 1, that implies that we're starting at that first term. Oh, sorry, not there. This one, the starting with the first term. So take note of how many terms there are by noticing that the k, if it starts at 1, this formula applies. If it starts at 0, then you'd have one more term in there. All right, so we're going to go to example 4. So from your textbook on page 716, and watch this video on example 4. And when so go ahead and pause this video, go watch example 4, and then come back here and we'll try some together. Okay, welcome back. So let's try some like that, where we have 31 through 40. So you're doing 33 through 40, every other on. So here's some examples. So again, we're using this formula and we're focusing on how to apply that. So that formula to find the partial sum of a finite geometric series. So here's, I need A1, the ratio, and how the number of terms in the series. So here A1 is that first term, so A1 equals 1. I have R is the ratio between one term to the next, so 4 over 1, or 16 over 4, or 64 over 16. So that's always 4, so each term I multiply by 4 to get to the next term. So that's my common ratio. And n, I find by looking at this term and thinking about the formula of this, so I can see that this is A1 times 4 to the n minus 1 times. So that means that n must be 1 more than that, so n is 10. Okay. So now I have everything I need to find the partial sum. So this partial sum, the 10th partial sum, is, using this formula, A1 is 1. 1 minus R to the 10th. Oops, sorry, R is 4. All over 1 over 4, or negative 3. So that gives me that one in front. I can just not write that and do 1 minus 4 to the 10th. 1 minus 4 is negative 3. I'm going to put that into the calculator, and I get 349,525. Okay, let's do another example where we have a little different notation here. So remember our summation notation here. The A is right here, so A1, I should say. So the initial term is the 2/3. And then this guy is the R. So the ratio, not the whole thing, this thing is the R. So the common ratio is 5. And our N, we're going from 1 to 9. So that's 9 terms. So that's 9. So our ninth partial sum is A1 times 1 minus R to the N over 1 minus R, which is, I'm going to need a calculator for that one. I'm going to do the calculator with you guys this time. So I'm going to start with this part. I'll do 1 minus 5 to the 9th. I'm starting with that because I know that fraction bar works like a grouping symbol. So I want to make sure that stays as a group and get that. So I hit enter. And then I take that and divide it by 1 over 5. So now I have 2/3 times 1 minus 5 is -4. So I'll take that and divide that by a -4, which gives me 488 to 81. And that I multiply by 2 divided by 3. And I get approximately 325, 520.67. And that ends the 9.3.3 geometric series.